Hi everyone. In this video, I'm going to be talking about different methods to solve quadratic equations. Now, we just recently learned about the quadratic formula and how the quadratic formula can solve any quadratic equation for us. However, that doesn't mean we should use the quadratic formula all the time. Okay? To me, the quadratic formula is kind of like a spork. Okay? Like a spork, it's useful in a lot of situations, but it's kind of clunky, it's kind of complicated, and it's not always the right tool for the job. So, for example, instead of using a spork, sometimes I would rather just use a spoon, or a fork, or sometimes I might want a pair of chopsticks. And just like using a spork sometimes, if you happen to use the quadratic formula on an equation that's much too easy for it, you might end up looking a little ridiculous. Okay? So what are the other methods for solving quadratic equations? Well, the first one, factoring. This was the first method for solving quadratic equations we learned this year. When should I be looking to factor? Okay. Well, first, let's make sure that one side of the equation is equal to 0. Okay, so we've tried to get the equation into standard form. And then if I see that c equals 0, meaning I don't have this constant term out here, this third and last term, then what I can do is factor a common x out of the first two terms. So x squared minus 5x factors into x, and x minus 5. And once I have the left side factored, from this I can see that x could be 0 or x could be 5. Okay? Much more straightforward than using the quadratic formula. Another instance where I might prefer to factor is if I see an easy trinomial. And by easy I mean something that I recognize, something that I've factored before. So for example, on the left side here I have x squared minus 5x plus 6. Now I've done this factoring problem before. This factors into x minus 6 and x plus 1. Now that I've fully factored the left side, I know that x could be 6 or x could be negative 1. Alright? Other methods. Second method is using the square root. I should be looking to use the square root when b equals 0. So here I have this x squared term, I have the constant term negative 44, but I'm missing the x term here that's usually in the middle. When I'm missing the middle term, what I'm going to be trying to do is isolate x squared. Okay? So I'm going to move the 44 to the right side, and then I'm going to isolate x squared by dividing both sides by 11, so I get x squared equals 4. And then I'm going to take the square root of both sides. And I'll see that x is positive or negative 2. Okay? Another time I'd be looking to use the square root is when I recognize a perfect square trinomial. For example, on the left side of this equation I have x squared minus 6x plus 9. I recognize that I can factor this into x minus 3 times x minus 3. And that's just x minus 3 squared. So I have a square on the left side. I'm going to take the square root of both sides. So x minus 3 is positive or negative square root of 10. Getting x by itself, x is 3 plus or minus the square root of 10. Another method for solving a quadratic equation is completing the square. Now with completing the square we did examples that were nice, where everything turned out to be whole numbers or square roots of whole numbers, and examples that were not so nice. Those had lots of fractions. So when is an example nice for completing the square? Well, it's nice when a equals 1. Okay? So when the coefficient of x squared is 1, so we don't have to divide the entire equation by anything. And when b is even. So like here I have negative 2. Why does this make it good for completing the square? Well, because I always have to take half of the middle coefficient and then square it. Okay, and if this number is odd, I'm going to be squaring a fraction, which I don't really want to do. So to complete the square here, I'm going to move the 1 to the right side. Then I have x squared minus 2x. I'm going to complete the square on the left side by adding the square of half of this coefficient, which is just 1, and I have to add 1 to both sides. I can then factor the left side into x minus 1 squared, and the right side is 2. And just like in the last method, I have a square on the left side and 2 on the right side, so I'm going to take the square root of both sides, and with x minus 1 equals positive or negative square root of 2. So x is 1 plus or minus the square root of 2. Okay, now finally we come to the quadratic formula. When should we use the quadratic formula? Well, whenever the first 3 methods don't work. Okay? So that means there's nothing we can factor, and the equation isn't set up for a nice completion of the square. Okay? So in this case, I can't factor x squared plus 7x plus 2 into anything. The 7 here, the coefficient on the x is odd, so if I have to complete the square, I'm going to have to be squaring 7 over 2, okay, which I can do, but it's not very convenient. So here, I'd rather use the quadratic formula. Let me write out the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in the values of a, b, and c, x is negative 7 plus or minus the square root. 7 squared minus 4 times 1 times 2, all over 2 times 1. Let's come up here. X is negative 7 plus or minus the square root of 49 minus 8 over 2. So x is negative 7 plus or minus the square root of 41 over 2. Okay? So let's just review here. We have, going backwards, the quadratic formula, completing the square, using the square root, and factoring. 4 different methods for solving quadratic equations. And it's important for us to recognize in what particular situation each of these methods works the best. Okay? So now going through these again, I'm going to leave you with this problem. 4x squared plus 4x plus 1 equals 0. Okay? So on your own, solve for x using any of the 4 methods we've discussed in this video. Okay? And tomorrow in class, we'll see which method people have come up with, and we'll compare which one seemed easier, which one seemed more convenient. All right? Have a great day.